9.3 goes over solving quadratic equations using square roots. These types of equations, you're going to have an x squared or a variable squared and a constant. Their whole idea with these is to get that x squared by itself. So move that constant over, divide by anything that's in front of that x squared, and then take the square root of both sides. When you take the square root of both sides, number one, you cannot take the square root of a negative number, so that would be no solution. Number two, the square root of 0 is just 0. Any other number or term that you're taking the square root of, you are going to have both the positive and the negative of that root. So if we look at example A, we have 3x squared minus 27 is equal to 0. We're going to solve this for x, not x squared, x. First thing we want to do is to get that x squared by itself. So we're going to add the 27 to each side to move it. We're going to have 3x squared is equal to 27. From here, again, we want that x squared by itself first, so we're going to divide each side by that 3, and we get that x squared is equal to 9. From here, you want x, not x squared. In order to get x instead of x squared, we would have to take the square root of that. What we do to one side, we have to do to the other side as well. So that's going to give us x is equal to the square root of 9. We're solving equations, so we got to include the positive and the negative of that 3. So we can just put that plus or minus sign right in front of our 3, and we have our answer. You can also write this as x is equal to negative 3, as well as x is equal to positive 3. They're the same thing. For example B, we have x squared minus 10 is equal to negative 10. For this one, we're going to bring that 10 over by adding it to both sides. That's on the same side as that x squared. It cancels out on both sides, so we just have that x squared is equal to 0. From here, we take the square root of both sides. 0 is neither positive nor negative, so x is just equal to that 0. For example C, we have negative 5x squared plus 11 is equal to 16. We want to move that 11 over, so we're going to subtract it from each side. This gives us negative 5x squared is equal to positive 5. We will divide each side by that negative 5 to get x squared by itself. So we have x squared is equal to negative 1. And then we will take the square root of both sides. You cannot take the square root of a negative number, so this one gives us no solution. In example D, we have negative 3x squared is equal to negative 75. We're going to start this one by dividing each side by that negative 3. Those cancel, so we have x squared is equal to a positive 25. From here, we take the square root of both sides, so we have x is equal to plus or minus 5, both the positive and the negative of that 5. And again, you could also give me x is equal to negative 5, x is equal to 5. It's the same exact thing. They mean the same. We have for E, we have x squared plus 12 is equal to 10. For this one, we're going to move the 12 over by subtracting it from each side. So we get x squared is equal to negative 2. If we take the square root of both sides, we cannot take the square root of a negative, so again, we have no solution. For example F, we have 4x squared minus 15 is equal to negative 15. So we're going to move the 15 over by adding it to each side. So that way we can isolate that 4x squared. It's going to be equal to 0. From here, we're just going to divide each side by that 4. We get that x squared is equal to 0. Remember, 0 divided by anything is 0. We take the square root of both sides, and x is equal to 0. And again, the only reason why we're not putting that plus or minus in front of that 0 is because 0 is neither positive nor negative. For the next set of examples, we're going to be looking at a binomial squared is equal to a number. When we have cases like this, we want to isolate that binomial squared, and then just take the square root of both sides. Remember, when you do that, you're going to have two answers. So from there, you're going to have to continue to isolate the x. So if we look at example A, we have x minus 1 squared is equal to 25. Our binomial squared is isolated, so we're going to take the square root of both sides. The square root of that 25 is both positive and negative 5. So we have x minus 1 is equal to plus or minus 5. From here, I'm going to separate this into two separate equations and solve for both. So I'm going to have x minus 1 is equal to negative 5, as well as x minus 1 is equal to positive 5. For the x minus 1 is equal to negative 5, we're just going to add the 1 to both sides. We have that x is equal to negative 4. For the x minus 1 is equal to positive 5, we're going to add the 1 to both sides, and we get that x is also equal to 6. So we have two solutions here, negative 4 and positive 6. For example B, we have x plus 7 squared is equal to 0. So again, our binomial squared is isolated. We take the square root of both sides. 0 is neither positive nor negative, so this is just x plus 7 is equal to 0. From here, we want to move the 7 over by subtracting it from each side. So we get that x is equal to negative 7. For example C, we have 4 times x minus 3 squared is equal to 9. That binomial squared is not isolated here, so we are going to divide each side by this 4. And we're going to have x minus 3 squared is equal to 9 over 4. From here, we are going to take the square root of both sides. We get x minus 3 is equal to plus or minus 3 over 2. Remember, the square root of 9 over 4 is the same exact thing as saying the square root of 9 over the square root of 4. So it gives you the plus or minus 3 over 2. From here, I'm going to separate this into two equations. We have one that's x minus 3 is equal to negative 3 over 2, as well as one that is x minus 3 is equal to positive 3 over 2. Remember, we want to isolate that x, so we're going to move that 3 over by adding it to both sides. 3 is the same thing as 3 over 1, which is the same as 6 over 2. So we're going to have x is equal to negative 3 over 2 plus 6 over 2, which is a positive 3 over 2. Same thing with the other equation. We're going to add 3 to both sides, which is the same thing as 6 over 2. So we have x is equal to 3 over 2 plus 6 over 2, which is 9 over 2. Both of these fractions are in simplest form without putting them or turning them into mixed numbers. So we just have the 3 over 2 and the 9 over 2 as our answers. For example D, we have 2x plus 1 squared is equal to 36. Our binomial squared is isolated, so we're going to take the square root of both sides. This is leaving us with 2x plus 1 is equal to plus or minus 6. We are going to move that 1 over by subtracting it from each side to begin with. However, I want to turn this into two equations, so I'm going to have 2x plus 1 is equal to negative 6, as well as 2x plus 1 is equal to positive 6. So now I'm going to move that 1 over by subtracting it from each side. We have 2x is equal to negative 7. And then we divide each side by the 2 to get that x is equal to negative 7 over 2. For our other equation, we're going to do the same thing. We're going to subtract that 1 from each side. We get 2x is equal to 5. Then we divide each side by the 2 to get that x is equal to 5 over 2. So our two solutions for this are negative 7 over 2 and 5 over 2. If we look at example 3 for A, we're just solving each of these equations using square roots and keeping each answer in radical form. So for A, we have 4x squared minus 13 is equal to 15. We're going to move the 13 over first by adding it to both sides. This is going to give us 4x squared is equal to 28. From here, we divide each side by the 4 to get x squared is equal to 7. We take the square root of both sides. You cannot take the square root of 7. However, you still have to keep it in radical form. So the square root of x squared is x. the square root of that 7 is going to say plus or minus the square root of 7. So anytime you cannot simplify your roots, keep them in radical form. Just make sure that you put that plus or minus in front of it. For example B, we have x squared plus 8 is equal to 19. We're going to start this one off by subtracting the 8 from each side. We have x squared is equal to 11. From there, we're just going to take the square root of both sides. We cannot take the square root of 11, so it's going to be x is equal to plus or minus the square root of 11. For example C, we have 5x squared minus 2 is equal to 0. For this one, that 2 is going to add in order to move it to the other side. We're left with 5x squared is equal to 2. From there, we're going to divide each side by the 5. We get that x squared is equal to 2 over 5. From here, we're going to take the square root of both sides. So we're going to have x is equal to plus or minus the square root of 2 over the square root of 5. Now, this is the same exact thing as saying x is equal to the negative square root 2 over the square root of 5, as well as x is equal to the positive square root 2 over the square root of 5. We said in previous sections that we cannot keep a fraction with the radical in the denominator. So we have to rationalize these denominators. We're going to multiply each of these numerators and the denominators by the square root of 5. So it just becomes that x is equal to the negative square root 10 over 5. Same thing with this one. We multiply top and bottom by the square root of 5. And we get that x is equal to the positive square root 10 over 5. So again, you want to make sure that you are including that plus or minus in front of your answer, as well as rationalizing those denominators if you have a fraction that has a denominator with a radical in it. For our last example that we're going to be doing within this section, we have 3x squared minus 30 is equal to 4. For this one, we're going to add the 30 to each side to begin with. We have 3x squared is equal to 34. From here, we're going to divide each side by the 3 to get that x squared is equal to 34 over 3. We are now going to take the square root of both sides. So we're going to have that x is equal to plus or minus the square root of 34 over the square root of 3. Your only factors of 34 besides 1 and 34 are 2 and 17. So you cannot simplify that square root of 34. You have a denominator that has the square root of 3 in it, so we're going to multiply the top and the bottom of this by the square root of 3. So we're going to get x is equal to plus or minus the square root of 34 times 3 all over the square root of 3 squared, which is just 3. Now, that 34 times 3 gives us 102. So x is going to equal plus or minus the square root of 102 over 3.